All right, today we're cracking open a new case file. But this isn't your typical detective story. Our lead investigator is an AI, and its mission? To solve the massive, complex mystery of why our cloud services go down. So let's get into it.
You know that feeling, right? You go to open your favorite app, check a website, get a file, and poof, nothing. It is so frustrating. But have you ever stopped to wonder what's actually going on behind the curtain during one of those outages?
Well, more often than not, it's basically a high-stakes manhunt. You've got a team of incredibly smart engineers, probably chugging coffee, frantically searching for one tiny clue. We're talking about a single line of code, or maybe one rogue server that's bringing the whole system to its knees.
And here's where it gets absolutely insane. The scale of this search, it's just staggering. A single cloud setup can spit out something like 200 million log entries every single hour. 200 million! Trying to find the one problem in all of that, it's not like finding a needle in a haystack. It's like finding a needle in a whole universe of haystacks. So yeah, that's what we're going to call the cloud's haystack problem. There's just so much data, and it's so complex that finding the real reason something broke is, well, it's a nightmare.
The thing is, the old tools, they just can't keep up. Traditional systems basically give you a yes or no answer. Hey, there's a problem. Gee, thanks, that's super helpful. They don't tell you what the problem is or where to even start looking. And it gets worse. In today's world of federated clouds, you've got these privacy walls between different regions, so they can't even share clues to solve the case faster. It's a real mess.
But what if you had a detective that was actually smart enough to deal with all this complexity? A true specialist in digital forensics, but for the cloud. Okay, it's time to meet our AI detective.
Its name is, get ready for it, FedHiGraphSAGE. Yeah, I know, it's a total mouthful. Don't even try to memorize it. What's really important is what it does. Its whole mission is to be this purpose-built AI that can dig through those millions of clues and hand you a super precise diagnosis of what broke and exactly where to find it. So if we break down that crazy name, you basically get its three superpowers. First, the graph part. It turns all that messy log data into a clear relationship map. Second, hierarchy. This is its 5-step investigation plan to hunt down the culprit. And third, federated. This is maybe the coolest part. It means it can learn from other systems. Think of them as different police precincts, but without ever having to share the confidential case files. Super smart.
All right, so let's pop the hood and look inside this AI detective secret toolkit to see how this all actually works.
Okay, so step one of the investigation. It takes that absolute chaos of raw log data, all those millions of separate clues, and it brings order to it. The AI builds what's called a graph, which is really just a fancy relationship map. It shows how everything, servers, storage, apps, how they're all connected and talking to each other. So once that map is built, the real detective work can kick off. And as the researchers themselves put it, the model uses this 5-level process to go from just a vague hunch all the way to naming the specific culprit. And this right here, this is a perfect look at that 5-step investigation. The best way to think about it is like a funnel, right? It gets more and more specific as you go down. So it starts at level 1. Super simple. Is there a problem? Yes or no? If it's a yes, boom, we're on to level 2. Okay, what kind of problem is this? Is it a full-blown critical error, just a warning, or is something just taking way too long? Got it. Now, level 3, is this a hardware thing or a software thing? Level 4 gets even tighter, identifying which application is acting up. Is it the compute, storage, or networking system? And all of that leads to the grand finale, level 5, which points its finger at the exact faulty module, the specific chunk of code that's causing all the trouble. It's this beautiful, methodical process from, uh-oh, something's wrong, to, aha, it's right there. And here's why this is such a game changer. Look at the difference. The old way just yells at you, anomaly detected. Great. But with FedHiGraphSAGE, the engineer gets a full, detailed report. It says, hey, you've got a duration anomaly, it's a software issue, it's in the storage application, and you need to go look specifically at the cinder.volume module. I mean, that's not a clue anymore. That's the solution. So let's circle back to that federated part, because this is really important. It means different cloud regions, or heck, even totally different companies can work together. Their own little AI detectives can share what they've learned, new types of failures they've seen, but without ever sharing the raw, super sensitive log data. It's exactly like detectives from different cities sharing their crime-fighting tactics, but never, ever sharing the confidential evidence files from their open cases.
Okay, so the theory is really impressive, but does our AI detective actually get the job done? Let's look at the evidence.
And when they put it to the test, wow, the results were pretty clear-cut. When you compare the accuracy of FedHiGraphSAGE against older models, it's not even close. In every single region they tested it, FedHiGraphSAGE just blew the others out of the water in terms of accurately diagnosing problems.
But if you want the real headline number, here it is, a 55.7% improvement in what they call path accuracy. What that means in plain English is that our AI detective is over 55% better at following the entire trail of clues and getting the final diagnosis right, across all 5 of those levels. That is a huge, huge leap forward. Now, of course, it's not always simple. Getting these kinds of results is a real balancing act. The researchers actually found that if you focus too much on one part of the investigation, say analyzing the text in a log message, it could actually throw off another part of the process. So they had to find that sweet spot, that perfect trade-off point to tune the model so it performs great across all 5 levels.
And this is so interesting because it shows the domino effect in an investigation. If you make a mistake early on, everything that follows gets messed up. What they found was that getting level 2 right, correctly identifying the type of anomaly, was the single most important step. If you get that part wrong, the whole rest of the investigation is pretty much guaranteed to go off the rails.
Okay, so we've established this is one seriously clever AI. But why should you care? What does this actually mean for us? Let's connect the dots. Well, the real-world impact is actually huge. For you and me, it means the apps and websites we use every day are just more reliable, less downtime. For the engineers, it's a lifesaver. They can fix problems in minutes instead of spending hours or even days on a wild goose chase. And on the grand scale of things, it lets us build smarter, more secure systems that can learn from each other to spot threats, all without anyone having to give up their data privacy.
So, when you boil it all down, it comes to this. This AI isn't just another tool for finding that needle in a haystack. It's like having a GPS that leads you right to the needle, points at it, and tells you exactly what it is and why it's causing a problem.
And that really leaves us with one big question to chew on. Our digital world is only getting more complex, right? More interconnected every single day. So as we head into that future, you have to wonder, will these AI detectives become the only ones who can actually keep the whole thing running?